So Carlos Nunez is one of the most enthusiastic DevOps practitioners that I think I've ever met. He's so excited, so smart and bright, and I tell you, he's young, but he has such a bright future ahead of him because he just gets it. And so I'm super excited about it. His talk is something that I find very interesting as well, which is why I chose it. But it's on the difference between configuration management and provisioning. And we're just going to clear up that whole mess in this next 30 minutes. So everybody, please welcome Carlos Nunez.
All right. Hey, everyone. How are y'all? All right, let's try that again, but a little less Monday morning, a little more DevOps Days Dallas, all right? How are y'all? Nice. That's what I like to hear. So, my name is Carlos Nunez. I work for a small DevOps consultancy out of New York called Contino, though I do live here, all about Dallas. And what we do is we help companies find that DevOps culture through cloud, containers, modernized platforms, and just breaking down silos. And that's part of what I'm going to talk about today on the difference between configuration management and provisioning. So before we begin, I want to start with a question. How many of y'all use configuration management tools? Hands up. All right, cool, a good amount of you. All right, so how many of y'all, oh wait, I think I forgot my clicker. That would have been really unfortunate. All right, how many of y'all are using configuration management tools to provision infrastructure, AWS, Docker containers, VMs, and VMware? How many of y'all are using configuration management tools to do that, right? Okay, fewer hands, that's all right. How many of y'all actually enjoying that experience? 2 people, okay. So I'm expecting some flames from you tomorrow morning on my Twitter, easiest name ever, or email, Carlos Nunez at Contino. But what I wanted to talk about today is why I think that disparity happens, why I think that complexity happens. So before we begin, I think it's important to talk about what I mean by provisioning in this context, right? So in this context, I consider provisioning and provisioning tools to enable you to create, modify, or delete infrastructure using code or APIs, right? And the code or APIs part, which is down here somewhere, is important. And the reason why that's important is because of where I came from. So when I started in this industry, I started as a Windows sysadmin, right? And when we started, we didn't really have these tools. So in the old world, we'd have to get the hardware, rack and stack it in your data center. If you were in a VMware type environment, you would do a bit of button clicking, spin up a couple of VMs, et cetera, right? And then you might have a runbook that tells you how to set that server up, whether it's a web server or a database, application server. You have some kind of a Word document or something to tell you how to do it. Or maybe you have some scripts that will help you facilitate that a little easier, something that someone wrote in a corner like 2 years ago or whatever, right? And maybe you have like a configuration management tool, SCCM in my case back in the day, Chef or Puppet or Ansible now, and then you just wait, right? But it was a long process, long drawn out process, very prone to human error, very prone to failure, very prone to 3 a.m. You're waking up and you're tired and trying to figure out what happened, right? In what I consider the new world or the more modern world, today's world, you still have to get your hardware, still have to get your VMs, still have to get all that groundwork set up. But with something like Terraform or CloudFormation, all you need to do is say, Terraform plan, right? I want to see what my infrastructure is going to look like when I run it. So I do Terraform plan, and that gives me that. And then I do Terraform apply to apply it. And as I do that, I become a very cute ferret in a hammock, chilling, because there's literally nothing else to do. And you want to be that ferret, by the way. It's very cute. So on that, the 3 reasons why provisioning tools are pretty great, in my opinion, is, and one of the biggest reasons is because of that infrastructure as code that lets you break down silos between teams. And for me, a big part of DevOps is having a common language to talk to teams so that you're not throwing things over the wall. You're talking in the same language. And Terraform or CloudFormation or tools like that let you do that through something that's pretty readable. And I want people to read this real quick, like 10 seconds. And I'm not expecting anyone to learn how to code or know how to code. It's totally fine. How many of y'all can kind of understand what's going on there? Okay, that's the point. Something that everyone can just sit down and read. That's my biggest reason why I like it. And because of that, you get to save a lot of time. And you get to save a lot of time through not having to reinvent the wheel so many times, through writing complicated scripts to do things, right? And because you save time, your money doesn't grow wings and fly away, right? You get to keep it and do cool stuff with it. And the third biggest reason why I like provisioning tools, and that unfortunately I won't cover today, but would like to cover at some point, is that because it's code, you can test it, right? You can write testing against it. You can say, how can I guarantee that my Terraform configuration will actually create the data center that I wanted to create, right? I can move beyond plans and go into automated testing so that you're not waking up when something goes wrong, or you're not just relying on looking at the plan. You're doing more proactive things on that, right? So no fragile infrastructure is a big thing for me with these tools. And to hone in on that a little bit, I want to just do a little example here. So this, I actually misnamed it. It's actually main.tf for those of y'all who use Terraform. How many of y'all use Terraform or played around with it? Awesome, cool, so a few hands, great. So you probably spotted this. So this little example here is going to create a EC2 instance in my AWS virtual private cloud or in the public internet. And I'm going to give it an AMI or machine image ID and a number of instances I want to create, as well as a subnet ID and a bunch of other things there, right? So this is going to create my instance. How do I create it? Let's take a look at the bottom right here, right? So I say, all right, Terraform, plan me my deployment with 1,000 of these instances. I want 1,000 potential web servers, right? And then it's going to scroll forever because it's 1,000. It's going to tell you I'm going to create 1,000 servers that look like this. I want to create them. Terraform apply. Done. Boom. You just created 1,000 EC2 instances. I said Ansible is Terraform. Sorry about that. But you create 1,000 instances in Ansible. Amazing. Just like that. Super easy. So that's how provisioning tools work. Now let's talk about what I mean by configuration management. And I should tread lightly here because Adam is here. So I don't want to, I'm expecting flames again. But the way I define configuration management here is that it allows you to express the state of your infrastructure with code or APIs. Again, like provisioning, it's all about using a high-level domain-specific language to express what your infrastructure looks like. So if I want to create a web server or a database, configuration management lets me say what that actually looks like, right? So that gives me a few advantages. The first advantage is that it gives me consistent and repeatable infrastructure, because I know that when I run Ansible against all of those 1,000 instances that I created with Terraform, then they're all going to be web servers and they're all going to look like how I specify. And it's big. That saves you a lot of time. You don't have snowflake servers. You don't have fragile infrastructure, okay? And to hone in on the point, again, it's a simple domain-specific language. So you can literally look at this and not know anything about how to code, never seen code in your life, and have a really good idea of what's going on. And that's big because that means you could take it to your management team and say, or take it to a development team and say, this is what y'all are running on. This is what your infrastructure for your application looks like. Really big advantage that I've seen work beautifully in a lot of environments. And third, because it's based on APIs and code, you can just scale it up, right? So if you're using Chef, you can write custom Ruby if you know how to write Ruby, or if you want to learn how to write Ruby. In Ansible, you can use Python to do more than what it just if the language is too simple, you can extend on it, right? And to give you an example of how this works, the code that I have here installs a small application called Tree, right? And Tree if you spend a lot of time in the terminal like I do, Tree is pretty convenient because once you run it, it shows you a listing of directories in a cute-looking tree. It's kind of nice, right? So I want to install this on some servers, right? So I create something called the Ansible playbook, which does this, and I say, let's install a tree with sudo, and I want to install stuff, and the stuff is tree, right? So I run this, and then on the bottom, I say which hosts are supposed to get tree. useless server happens to be the example here, but this useless server is going to get tree when Ansible runs. And all you do is you do Ansible playbook, I forget, Ansible playbook v 4 V's run or something, I forget. But you run Ansible and you get tree on useless server, and it's just as easy as Terraform, like similarly easy. It's really powerful when it works, right? So now you're all looking at this and you're saying, well, Ansible is really easy. It's just YAML, right? So I can just do anything with it. So let's deploy some EC2 instances. Let's deploy some VMware machines. Let's set up our hardware this way, right? No, let's not do that. What do you mean? Like, why can't we do that? It's Ansible. We can do anything with it, right? The problem is that with Ansible and Chef and Puppet and tools like it, there's a cost to idempotency. Okay, I practiced this yesterday. There's a cost to idempotency, right? And as y'all can tell, I learned this word like about 1.5 years ago, and I looked at it. I'm like, this is not English. I'm not even going to pronounce this. But it turns out you can either pronounce it idempotent or idempotent. But I prefer the latter because saying it the former makes me feel weird. So there's a cost to idempotency, right? And what I mean by idempotency, and I actually have the definition in my phone, so I'm going to read it real quick. So from Wikipedia, it's a mathematical concept, and the idea is that idempotence is a property of certain operations that can be applied multiple times without changing the results beyond the initial application. So when I run my Ansible playbook or when I run my Chef cookbook, the idea is you can run that any number of times, but the end result is you're going to have your web server, you're going to have your database configured to your liking. But there's a cost to that because Ansible or Chef don't necessarily care about what was there before. It's like a tractor or like or I don't know, garbage truck. Think of some big thing. It just plows through, right, and just does exactly what you need it to do. But with infrastructure, there's relationships that exist, right? You have AWS instances and security groups. You have firewalls, you have load balancers, and they're all interconnected. And when you try to shoehorn this concept into Ansible or Chef, you start to, at least in my experience, run into problems. And before I go into the problems I'm going to outline, share a small story here. So a few years ago, I was given a project to spin up an Active Directory forest, completely automated from scratch. So instances, then the forest, then the domain underneath, then the domain controllers, then the domain. And I was going to do it all with Ansible. And I'm thinking, when I first started, Ansible is great. I can totally do this. And so I went through, and at first it was really easy because I was able to create my instances, and I was able to then provision my instances with Active Directory, with PowerShell. It was great. But what I soon realized is trying to associate security groups with those instances became really difficult. And then trying to associate changes in tags and changes in anything after that got really, really, really hard. And the easiness got me 80% of the way there, but the 20% was kind of like that, what did Adam call it in his presentation? The peak of hope or something, right? Where it seemed all great until I hit that point, and then it was just suffering from then on out, right? It took me about a month to write that, and by the time I was done, we landed up never using it. So it was kind of sad, and that's why I'm up here. So, so let's take a simple example real quick, right? So I have a playbook, and it's going to deploy my instances, like I said before. And after those instances are created, I'm going to use it to provision. I'm going to use Ansible to both create the instance as well as configure that instance with Nginx, right? This seems super simple, y'all. Like, I mean, it's really straightforward, right? Pretty easy to understand. But if we look at the exact count, which is the third, the fourth line, fifth line from the top there, that tells me how many instances I actually want to deploy. But how can we actually guarantee that, right? How can we actually guarantee that Ansible knows, A, that there are 1,000 instances, B, that those 1,000 instances are connected to each other, and C, like, what relationships already exist? Like, it's not really something that Ansible's strong at. So how can you actually guarantee that this is already there? Well, you gather state externally. And how many of you have used the AWS command line? Cool. So you already know that with the AWS command line, you can go in and do describe instances and say, hey, Amazon, tell me how many instances I have that match this particular filter, right? So I say, I do this in my Ansible playbook, and I get a result back, right? And then I can use that to say, okay, I can be pretty sure that there's 1,000 instances of this type, right? So sounds good, right? Not really, because now we need to consider what happens if that tool's not installed on your Jenkins slave that's running this, or what happens if that tool gives you some crazy output, like if EBS goes down or if EC2 goes down in an availability zone. What am I going to do with that unexpected output? Or what happens if I'm on a boat, which I'm hardly ever on a boat. Maybe some of y'all are on a boat more than me. Or you're all in the mountains or somewhere where you don't have a real rock-solid internet connection and you're trying to deploy this. And it takes forever to get some results from AWS back. How do you account for that latency? Well, now we're starting to get really, really in the deep of it. So now we want to probably abstract this away from our consumers of this cookbook or this playbook. So we modularize it, right? Like we put everything in like a nice little module that handles all these use cases, and then we abstract it away so that in our playbook we just refer to it by module, right? But then there's relationships that I mentioned before, like security groups. When you're creating a web server, there's going to be some security groups. You don't want that thing open in the wild because that's how you get hacked in 5 seconds, right? So how do you create security groups dynamically with Ansible? And you can. I can guarantee you 100% you absolutely can. But I think and I hope that the point that I'm trying to make here is clear. You're writing scripts again. Like if I can't, I don't know how to go back on this thing. But you're writing scripts again. You're back in the old world where you're writing that runbook, that really complicated script that people can't really read. And now you're losing the whole point of using something like Ansible, which was to be a really easy language that anyone can just pick up. And now you have stuff being thrown over the wall because it's really complicated, and it just gets really messy, right? So you lose the simplicity. And it's good to embrace complexity, but it's also good to embrace ease of use, like Adam mentioned earlier beautifully. And once you start going down this path, it just gets really hard to come back from because you're really in the deep of it. So something like Terraform solves this really well because with Terraform, it's all accounted for you. It keeps track of your state automatically. There's nothing to think about. And all you do is you write your TF that says, I want a web server, and then you can use Ansible once those are configured to run it. And Terraform supports that really nicely. So you gain that simplicity back, and you're now talking to your developers just like any other team. So it's a really nice model to work in. The other thing I wanted to talk about that I briefly touched on is that when you use configuration management tools to provision your infrastructure, you have to keep track of your environment state yourself. And what I mean by that is, going back to our web server example, I want to add a tag that denotes a cost center. How's this instance going to get charged, and who is it going to get charged to, right? So I want to add these tags. But I already deployed my 1,000 instances. So how do these tags actually get there, right? Like, what happens if I run this playbook right now? Anyone want to take a guess? What happens if I run this playbook right now? I love the silence because I agree. Nothing happens, right? Nothing happens when you run this playbook because you already deployed your 1,000 instances, and Ansible doesn't know that those instances are necessarily connected to the playbook that you ran. So now you have to find some way to tell Ansible to detect this and automatically update it, right? So again, with Terraform and CloudFormation, you don't have to worry about that because it does it for you. It automatically keeps track of that state for you, so you're not writing boilerplate to account for this. So you get simplicity and you get statefulness. Also, another thing to consider is this can fail in the middle of a deployment. So what happens if we're running this playbook, right, and it's all in the middle of it, and EBS, the Elastic Block Service, dies, right? So your instance doesn't get created. So what happens then? Anyone want to take a guess at this? Nothing happens again. Great job. Nothing happens because it rollbacks on you in this case, right? And for those of you who's Terraform, Terraform explicitly states that it doesn't roll back in the face of errors. But with Terraform, it already knows when something isn't right and marks it as tainted, which is a word that it's a Terraform specific word. I think CloudFormation has a different terminology for it. But if a Terraform deployment fails, it knows, okay, I have these instances that I created and some of them aren't right. Some of them aren't right as denoted by my state. Let me go and destroy them automatically and recreate them again, right? To do that with Ansible, again, or Chef or anything, you can 100% do it in those tools, but it just gets really complicated, right? And again, it's all about usability. At least for me, or at least what I found, it's all about usability and ease. So with that, I want to start ending this talk on a couple of tools that y'all can use that will help you with your provisioning journey, right? So I spoke about Terraform a lot, and for good reason. One, I do run HashiCorp DFW. Come to my meetups. But in reality, the reason why I advocate for Terraform so highly is because it's a really great tool that's written with usability in mind, and it's also vendor and cloud agnostic. So you can run it on AWS. You can run it on your own hardware. You can run it in OpenStack, IBM, SoftLayer. You can run it on just about anything. And if there's something that it doesn't support, you can write a provider that supports it. So I highly recommend taking a look if you haven't already. If you're very committed to AWS, and AWS is where you're going to live as an organization, then CloudFormation is actually a really great tool to consider as well. It's very similar to Terraform. It accomplishes the exact same thing in that it automates the deployment of your infrastructure for you. But the biggest advantage with using CloudFormation is that because it's a first-class service that AWS offers, it supports all of AWS's service in some situations a lot faster than HashiCorp's AWS provider does. And if you're trying some crazy new service like Snowball and you want to have that automatically supported in CloudFormation, you can do that most likely. So it's something to consider. The last big service that does automated provisioning for you and for y'all folks that are on OpenStack is Heat. So how many of y'all how many of y'all are on OpenStack right now? Wow, the one Lone Ranger on OpenStack. Amazing. So you already know all about this because OpenStack is kind of difficult. But Heat is very similar to Terraform in that it supports OpenStack services like Glance, Horizon, and Nova. And it just makes that integration a lot easier. Terraform also supports OpenStack, but its support is rather limited. So if you're on OpenStack, like my lone man over here, consider Heat. And the two tools on the bottom I haven't actually spent a lot of time in, but when I did research, they did come up, so I wanted to spend some time on them. So there's Cumulus, which is another provisioning tool from the ground up. It's kind of a new contender in this space, so if you like the bleeding edge, take a look at that. Also, Sparkle Formation is a wrapper around CloudFormation, which now that CloudFormation supports YAML, I'm not sure how useful it is, but it's worth taking a look if you find CloudFormation to be a little too limiting. So the last thing that I want to mention, or the last question, or the question that I want to address that I'm sure some of y'all are thinking is, Carlos, you spent 5 years building Chef and Ansible in our company. Are you trying to tell us that we're dumb and that we have to trash everything that we did and we should be using Terraform for everything, right? Like, can we use these things together? And the answer to that is yes. And no, I'm not trying to say that you're stupid and that all your work is lost. I think they actually work really well together. And the point that I'm trying to make here is that configuration management and provisioning are different. And to stick to the tools that do the job best, right? So use a provisioning tool to provision your infrastructure, and then use a configuration management tool to lay down the configuration. And if you do it with that pattern, you'll find you'll find that your life will just get a lot easier, and you won't have to spend so much time writing a lot of custom code to try and do what you want. So in closing, I had a closing slide, but unfortunately didn't make it in here. What I wanted to discuss with y'all today is, again, configuration management and provisioning are different. Configuration management manages what your infrastructure looks like and provisioning lays down that infrastructure. So pretty big difference. And the difference mostly comes to state. State is important, and a configuration management tool doesn't necessarily give you the management of that state easily. Relationships are important with infrastructure, and trying to account for them in a configuration management tool will get quite complicated quite fast. And the last thing that I covered is some tools that you can consider on this journey, Terraform and CloudFormation being the two top contenders, and Heat and others being useful in some other niche situations. So with that, thank you all for listening to me for 30 minutes. I'm happy to be here. Thank you.